Okay, today's class we're talking about prefixes used in the metric system, which I listed here. We're going to look at how to convert temperatures, and we're also going to learn how to convert volumes. The first thing you need to do is to memorize the prefixes related to the metric system. The ones that most people know are, because they have computers, are related to the kilo, mega, and giga. Kilo means 1,000, mega means you multiply something by 1,000,000, giga means you multiply something by 1,000,000,000. So if you have a 500 megabyte hard drive, it means that it can store 500 million pieces of information, and that would be a 0.5 gigabyte. So each succeeding prefix is worth 1,000 times than the one before it, until you get to within 1,000. So a kilo, they break it down to every 10. So you see hecto, which is times 100, deca is times 10, deci is 1/10, centi is 1/100, and milli is 1/1000, and then it continues again with the pattern of increasing by thousands at every jump. So micro is 1,000,000, nano is 1,000,000,000, pico is 1,000,000,000,000, femto is 1,000,000,000,000. And for most purposes, femto is as low as you're going to get, although there are even smaller prefixes, and there are also bigger ones than giga. The one above giga would be tera, which is 10 to the 12 or a trillion times. Here's an example of one of the questions from your textbook, which is Brown, 10th edition. It asks how much is 1 picosecond in units of seconds. So a pico means something that is 1 trillion, 10 to the minus 12. All you have to do is write times 10 to the minus 12 to find out that it's 1 times 10 to the minus 12 of a second. The next question asks how much is 6.0 times 10 to the 3 meters using a different prefix. So 6 times 10 to the 3 is the same as 6 times 1,000 or 6,000 meters. If you want to change the prefix to kilometers, then you can write 6 kilometers and you divide by 1,000 for the number. If you want to convert 3.76 milligrams into grams, milligrams is 1/1000th of a gram. So 3.76 times 10 to the minus 3 is what you get when you divide this number by 1,000, because a milligram is 1/1000th of a gram. Switching to the next board, we're going to look at how to convert temperatures. In chemistry, we need a temperature scale that starts at 0. So the Kelvin scale was designed precisely for that. It's the same as the degrees Celsius scale. A degree Celsius is the same size as a degree Kelvin. The only difference is that the Kelvin scale has been slid down by 273 degrees. So 0 Kelvin is actually equal to negative 273.15 degrees Celsius. That's the lowest temperature you can reach in the universe, and it's called absolute zero. At absolute zero, the temperature, the molecules in any matter have no heat energy. You can't get colder than that because there's no heat energy left to take out. And all gases will turn into solids at that temperature. If you want to convert from Celsius to Kelvin, you take the Celsius temperature, you add 273, and it'll give you the Kelvin temperature. So if you're at 0 degrees Celsius, it actually equals 273.15 Kelvin. And if you're at 0 Kelvin, it equals negative 273 Celsius. If you want to convert from Fahrenheit to Celsius, or from Celsius to Fahrenheit, you have to use one of these two formulas. If you have the Celsius temperature, you multiply it by 9/5, and then you add 32, and it'll give you the Fahrenheit temperature. If you have a Fahrenheit temperature, you subtract 32, and then you multiply by 5/9 to find the Celsius temperature. So you can follow the order of operations in the formulas. First you do the bracket, then you multiply. Here's an example. What is the temperature in degrees Celsius if it is 95 Fahrenheit? So you use this formula, 95 minus 32 times 5/9 will give you a temperature of 35 degrees Celsius. Conversely, if you have the sun's core temperature, which is 50 million degrees Celsius, what is that in Fahrenheit? You multiply the number by 9/5, and you add 32, and you get this answer, 27,032,000. Of course, 32 isn't significant. We're just doing it for the mathematical value of the calculation. Here's another example. If you have they ask you what the melting point of ethylene glycol is negative 11.5 Celsius. They ask you to convert that to Kelvin. So you add 273.15, and it gives you 261 Kelvin. Likewise, they ask you to find the temperature in Fahrenheit if it's negative 11.5 Celsius. You subtract 32, and and you multiply by 5/9, and the answer is,
I'm just going to double check that because I'm noticing something.
oh, it's not negative, it's positive. That's what I did by.
It's positive 11.38 Fahrenheit.
Okay, you have to add 32, that's what I forgot to do. You add 32, and then you multiply by 5/9, it gives you positive 11.38. Just fix that in your notes if you wrote it down wrong. Now the next thing I want to look at is converting volumes, which is a real stumbling block for many students. We have length, area, and volume. Normally length is measured in meters, area in meters squared, and volume in meters cubed. But when you want to convert from meters to some other unit of measure that is acceptable, say centimeters, you have to keep in mind that when you have a two-dimensional or three-dimensional object, you have to multiply each one of the dimensions in. So if it's a linear conversion factor, it's very straightforward. 1 meter is equal to 100 centimeters. But if you have a square meter and you want to turn it into square centimeters, you have to multiply by 100 centimeters by 100 centimeters because there's length times width in area. So 100 times 100 will give you 100 squared centimeters squared. That equals 10,000 centimeters squared. Sometimes students are surprised to see how big the numbers get when you change the units. And if you want to convert a volume of 1 meter cubed into centimeters cubed, you have to keep in mind that you're multiplying 3